So this one here, when you differentiate it, now remember from your formula sheet, on your formula sheet it says log x to 1 over x. So it says natural log x 1 over x. Okay, so that's why that's your differential. Okay, so what this is natural log of 3x, so it's going to be 1 over 3x. You happy with that part? But the chain rule says we have to multiply that by the derivative of the function. 3x, the derivative of 3x is, okay, so 1 times 3, 3 over 3x is actually just the same as 1 over x, okay? Happy with that? In other words, let u equal 3x, okay? So y is log of u. Happy with that? So far what I've done is I've just said let u is be this part here, and so y is actually log of u, natural log of u. Happy? So dy, when I differentiate y with respect to u, that's what dy by du actually means, from our formula sheet, that's just 1 over u, is it not? Happy with that?
Yeah.
When I differentiate u with respect to x, I differentiate u with respect to x, that's regular an answer of just 3. You happy with that? So remember, if we want dy by dx, to get that we're going to go dy divided by du and times that by du by dx, because what happens when I multiply that out? Yeah, those parts there, you can imagine them as cancelling out, okay? So that's just dy over du, which is 1 over u. Du over dx is just 3. So there's my answer. Is that right? But dy by dx needs to be x's rather than being u's. So from here again, substitute that into there. 1 over 3x times 3, which again, as you just saw, is the same as 1 over x. Okay? I'm going to keep showing you these long ways, and hopefully after a while they're going to start to sink in and potentially make a little bit of sense. Who's following the long way anyway and going, okay, I'm actually starting to see what's going on here. So a few more people putting their hands up, which is good. Next way, what am I going to do there? Dy by dx. Do you want the long way or the short way?
Short.
Both?
Short.
Which way you want first?
Short.
Okay, short. You would. So, what am I going to do there first? Who thinks they've got this answer anyway? What do you reckon, Sam?
No idea if it's right or not, but I ended up with 7x over 2x squared minus 4.
So you're going to have it over 2x squared minus 4.
So I have 3 over that.
Yep.
Times 4x.
Yeah, okay, so how'd that become 7? Yeah. Yeah, you did. And that is correct. Yep. Okay, so you're wrong, but you were right. So, can you see, because you're taking the natural log of this part here, that goes on the bottom part of your fraction, and this is just 3 times that. So if you differentiate 3x squared, or just 3x, what happens to the 3? Sort of stays there, eh? If you do 3x squared, then that multiplies by the 2. But the 3 stays there because that's just a constant. And so why did you multiply it by 4x?
because that's the derivative of
That's the derivative of that part there. Okay. Happy with that? Beautiful. Yep. Okay, so now if we go the long way, I'm going to say let u equal 2x squared minus 4. So du by dx is just 4xa.
Yep.
So that's the derivative of the bracket. The derivative of the bracket is what we're going to multiply it by eventually. Remember, u is the bracket, isn't it? So y therefore is 3 log u, and when you differentiate y with respect to u, you are going to get 3 over u. Happy with that? So therefore dy by dx is going to be 3 over u times this 4x C2. Look at that, it's written down 5 times. 4x. Happy? But we're going to write that down in terms of x's rather than being u. So that's just going to be 3 over 2x squared minus 4 times by 4x. 3 times the 4 gives you the 12x, which is what we have over here. Happy with that? Starting to get the hang of that? Bit more practice, we'll get there.